Hi there. This is going to be day 2 of thermochemistry. Oh, that's from the beginning. So let's get to day 2. We did all of this already. Energy transfers, enthalpy. And there we go, day 2. So today we're going to talk about heating curves and phase diagrams, like phase changes, changing when liquid evaporates and becomes a gas, those kind of phase changes. Okay. There are 3 basic states of matter that we're going to talk about. We talk about solids in that they have a definite shape and a definite volume. So if you think about a desk or a book, that has a definite shape and a definite volume, and that doesn't change. Liquids, their shape can change, but their volume stays the same. So think about if you had a bottle of water. If you have a bottle of water, it has the shape of the bottle, but let's say it's still just half a liter. Well, if you pour that half liter bottle of water, pour the water into a different type of glass, the shape would change, but the volume stays the same. Gases will change shape and volume to match their containers. So the more space, the more volume you allow that gas, the more space it'll take up. Matter can change from one state to another, and there are 6 possible state changes. You probably are familiar with most of them, but maybe there's a couple that you might not be familiar with. For each one of these, energy is either going to be absorbed or it's going to be released. So these are the 6 phase changes. Freezing is when something goes from a liquid to a solid. Condensation, that's when something goes from a gas to a liquid, like when in the summertime when the humid air outside touches your cold window from the outside, that the water in the atmosphere will cool and condense into a liquid on the outside of your windows. Evaporation is when something turns from a liquid to a gas. If you leave your dog's water bowl out on the porch long enough, it's going to all evaporate. So sublimating, you may not be familiar with that term. When something sublimates, it goes from a solid directly to a gas. Something that you are familiar with, probably, that does this is dry ice. So dry ice doesn't leave a puddle on the floor. Dry ice goes from that solid block of carbon dioxide directly to a gas. So that's sublimation. Melting, you do know, when something goes from a solid to a liquid, like if you leave an ice cube out on the counter, it will melt. And deposition is the opposite of sublimation. When you freeze carbon dioxide gas, it will turn to a solid. So these are our state changes, going from solid to liquid to gas, and then sometimes from solid to gas, gas to solid. Entropy is a new word for you. Entropy is the measure of randomness and disorder in the universe. I imagine that your room is probably a study in entropy, or at least my kids are. So when entropy increases, the randomness increases. So solids have very little entropy, and as entropy increases, something would turn to a liquid, the solid would turn to a liquid, and then even more entropy, liquids would turn to a gas. So higher entropy would be something like gas, solids would have less entropy. The universe consists of matter and energy doesn't have mass that take up space. Energy is involved when matter changes from one state to another. So when you have a solid, let's say you have ice, and you leave it out on the counter, well, the heat, remember, heat travels from areas that are cold to areas that are warm. The heat energy around that ice cube is going to cause that ice cube to turn into water, or it's going to melt. What happens to the temperature of a block of ice when you put a Bunsen burner underneath it? Well, duh, that block of ice is going to melt. You might think that the temperature goes up very smoothly, because that's kind of what it looks like. You know, it looks like things melt very smoothly. That's actually not what happens. The graph of temperature versus time is called a heating curve. Okay, we're going to look at the heating curve for water. So the heating curve for water, anything below 0, so over here you have temperature, and then you have time over here. So anything below 0, that water is ice. Okay, it's a solid. And you'll notice that the temperature does increase smoothly until it gets to 0. Well, if you keep adding heat, if it keeps absorbing heat from surroundings, that ice is going to try to turn into liquid water. Ice at 0 degrees C absorbs heat and melts at a constant 0 degrees C to make water. So once all that ice has melted, once it's a liquid, it starts to absorb heat again. The liquid starts to absorb heat until it reaches 100 degrees. At 100 degrees, water boils. Okay, what's happening in that part of the phase change right here where water is boiling, water is attempting to turn from a liquid to a gas. Okay, it absorbs heat. So that curve flattens out at these spaces where the phase change is actually occurring. Once all of the liquid water heats up, temperature rises, and it boils, and so that's where the water continues to heat up, and now it's gaseous water. Okay, it's steam. So we need to label these in your notes. You need to make sure that you know what is happening everywhere. So this first part I told you was ice. It was solid. Here in this flat portion is where ice and water are existing. The ice is trying to turn into liquid water. Well, then it's all into liquid water and it continues to heat. It continues to heat till it hits 100 degrees where it is water and steam. Okay, once that water is all turned to steam, then there you go. The heating curve, that's where steam is, where the water has turned, all of the water is turned into steam. So what are the phase changes? Okay, what's happening? Okay, what happens here? As you're moving from left to right, that ice is melting. That's the phase change. What's happening here as you move from left to right? As you move from left to right, the water's boiling. But let me ask you, what happens if you're down here, okay, and you're moving from right to left? What is happening here as you move from right to left? As you move from right to left, liquid water is trying to turn into ice, so it is freezing. So the freezing point and the melting point are the same thing. They're at the same temperature. So how about up here? You know, as you're moving from left to right, it's boiling. But when you're moving right to left, where the gas is becoming liquid, what's happening? That's condensation. Right. So the condensation point and the boiling point, same temperature. Okay. The temperature is constant during a phase change. See these flat portions of the graph? Until all the ice has turned into water and until all the water has turned into steam, temperature doesn't change. It's constant. The freezing point I told you is also the melting point. Okay? And then the boiling point here is also the condensation point. Okay, just one more picture of the graph. Okay, this is a little flash program. We'll see if it'll work for you here. See if we can't get it to come up and work. Oh, okay. Nope, I guess not. Adobe Flash Player isn't working. So it's just showing you how as heat is added, that the ice turns to liquid water and liquid water turns to steam. Nothing fabulous. Okay. So why is the curve flat at some portions, like here from B to C and D to E? During phase change, the temperature stays constant. This time, solid is completely becoming a liquid, or liquid is becoming solid, or liquid's becoming gas, or gas is becoming liquid. Okay, that's why it's flat. So between which 2 points is water boiling? Right, between points D and E. What is the phase change? What's the phase change called as you move from B to C? Right from B to C. Melting. Good. Ice is melting. What's the phase change as you move left? Move left from point E to point D. As you move from E to D, condensation. I think I told you a minute ago you're going right to left. I really do know my right from my left, but I said the wrong thing. So left to right is condensation. Right to left is boiling. Left to right is freezing. Right to left is melting. Sorry about that. Okay, number 4. What's happening between points D and E? So between D and E, what's happening? Right, it's staying the same because all that liquid water is trying to turn to a gas. What's happening to temperature and energy as you move from point D to point E? I'll give you a second. D. Temperature stays the same as it boils. So this is called a phase diagram. A phase diagram shows the phases of matter, solid, liquid, gas. It summarizes the effect of temperature and pressure on a substance in a closed container. Every single point on this diagram is a possible combination of temperature and pressure for the system. The diagram is divided into 3 areas which represent solid. So here is a solid, and look, temperature's low, that's where the solid exists. Liquid's in the middle, and then gas exists at a high temperature and a low pressure. These won't always be labeled for you, solid, liquid, gas, so make sure that you know what they are. Remember that solids are more common at low temperatures, like here where the temperature graph is. Over here are the lower temperatures. Over here are the higher temperatures. Gases tend to exist at higher temperatures. Point A right here, this is a neat little point. It's called a triple point. The triple point is where all 3 phases of matter exist at the same time. Okay, solid, liquid, and gas can coexist at a very specific temperature and pressure. This diagram right here that I'm showing you shows the triple point of water. So here's the triple point of water. Triple point of water is 0.01 degrees C, so barely over 0, and 0.006 atmospheres, which is very low pressure. This is low pressure, this is 1 atmosphere of pressure is sea level. So below that, pressure is increasing. So down here, right about there, that's the triple point where ice, water, and steam can all coexist. So we're going to do a couple problems using our phase diagram. Remember, C is gas, C is solid, B is liquid, A is a gas. Here's our temperature on the bottom, and here's pressure up the side. What's the temperature of the triple point on the diagram? Well, you're looking for temperature of the triple point. So here's my triple point right here where all 3 intersect. So it looks like about -15 degrees. Yep. If a sample of this substance is at 50 degrees C, and a pressure of 6 atmospheres, what phase is it in? What do you think's right there? Right, it's a gas. This is all gas up in here where A is. All of this is a gas. If the sample of this substance is at 0 degrees C and 30 atmospheres of pressure, keep going up. Ooh, that's barely. What phase do you think it is? Yeah, it's right there. Ooh, it barely fits in there. Where that B is where the liquid is, so it barely fits in there. If a substance moved from region B to region C, so I'm moving from a liquid to a gas, what phase change happens when you move from a liquid to a gas? It is not freezing. It is not freezing. Oh, that liquid to solid, my fault. Liquid to solid. As it moves from B to C, liquid to solid, it is freezing. B to A would be liquid to gas. Okay, so this is day 3, and we'll move on to day 3, and we'll do some calculations next time.